Hello, everyone. I'm Kendall Clark, and I'm here with Craig Casey, and we're going to be presenting this webinar on tunable white today. I'm going to start by doing a quick poll of your occupation. So we're trying to get an idea of who's here, and we can sort of tailor the presentation a little bit. So take a couple minutes and answer that poll, and while you're doing that, we are going to be using a few more polls throughout the presentation, so look forward to seeing those. There'll be similar multiple choice, very quick. We're also going to do a very brief survey at the end. You'll just be asked, basically, was this useful for you? We'd appreciate if you give us a little bit of feedback before you go. And feel free to ask questions throughout the presentation. We will try to answer your question during the presentation. If we don't have time to answer, or requires a longer answer, then we will send a follow-up email, and the most common questions we'll send out to everyone, so everyone has that information. All right, so I'm going to close the poll here, and just so everyone can see the results, we get a pretty good representation for lighting designers and electrical engineers, and then a couple of electrical contractors and facility management folks. All right, so back to the presentation. The agenda for this is we're going to do a color science overview. So Craig is going to handle that section. Then I'm going to talk about why tunable white and the applications and why you might want to use it. And I'll also cover questions that you should ask on every job to help minimize risk, make sure you get a good solution. And then I'll go into specifically how Lutron can help reduce your risk and the Lutron solutions that you can use to do that.
Hello, as Kendall said, my name is Craig Casey. I'm here to cover a couple of sections, but we're going to start right here with the color science overview. So I'm going to give you an explanation of correlated color temperature and a chromaticity diagram. I'm going to talk about warm, dim, tunable white, and the difference between two different fixture styles. And I'll cover full spectrum control briefly. So here we go. So correlated color temperature, if you're not aware of what that means, it's basically a way of describing the color appearance of a light source. So it's measured in degrees Kelvin. The higher that temperature, the cooler it appears, and the lower that temperature, the warmer it appears. So if you think about a piece of metal that's been heated in a fire, you can see that the higher side actually does appear cooler, whereas the lower temperature of that object would actually appear warmer. So that's kind of why we get this inverse of temperature versus appearance. But this is correlated color temperature. You can think of an incandescent lamp as somewhere around 2700 Kelvin. Halogen would be 3000. A lot of interiors are 3500 or 4000 Kelvin with fluorescent. And a dimmed incandescent would be somewhere around maybe 2000 degrees Kelvin, depending on the dimming level. The chromaticity diagram is a color space for us to be able to do various calculations that we need to describe color. In fact, the line that you see going across the middle of that diagram is how we calculate correlated color temperature. So you can see the different temperature lines there. Around the outside would be monochromatic light. So if you just had a single wavelength of color of light, that's where it would plot around the outside. So if you think about the electromagnetic spectrum from UV to visible light to infrared, if we take that visible portion, that's what's wrapping around the outside of this diagram. And so this is the way that we can calculate things like CRI as well, or other metrics in addition to these. But this is kind of the premise for some of the conversation that we're going to have later. So coming from the lower right, arcing across that line, you see that you get increased correlated color temperature, and whichever line you're closest to is kind of how we determine what correlated color temperature you actually are. The line is actually known as the black body locus, which is a black body up until about 5,000, and then after 5,000, that's how we calculate or reference daylight. So the first technology I want to talk about is warm dimming. So here you can see the reason for that is really to provide an incandescent-like experience. So with LEDs, we hope they don't naturally change color when dimmed, but people like the feeling of an incandescent lamp, which as it dims, it decreases temperature and therefore actually appears warmer. That CCT change is automatically happening within the light source itself, and the only thing that you need for that is just a standard dimmer. That's all you need. You control the intensity, and the light source actually changes the correlated color temperature. So what you might be able to think of when you see this is really commanded level versus light output. So if you command the light level to 100%, then the light output would be 100%, and that's going to be the coolest state in appearance of that light source for a warm dim source. As you dim, you can see that you're getting warmer and you're decreasing light output. So the only thing you can do is achieve basically that line that you see there from 100% down to 0. You cannot achieve a warmer color appearance at a cooler color appearance at a lower intensity. You can only get high correlated color temperature at high output and low correlated color temperature at low output. How does this work? So if we take that chromaticity diagram, if we start at 3000 Kelvin, that would be the full light output. That's about a halogen incandescent. And maybe we dim it to 50%, we're somewhere around 2400 Kelvin. And finally, right before it turns off, we're somewhere in the neighborhood of 2000 Kelvin. That would be how the warm dimming would work on the chromaticity diagram. So now we're going to kind of change and switch to tunable white. And this is something that gives you the ability to adjust both color and intensity, or rather you can have any color at any intensity, is how we like to talk about this with tunable white. The first fixture style I like to talk about is a warm, cool fixture. So this means that there's a warm set of LEDs controlled by one driver and a cool set of LEDs controlled by another driver, warm and cool, right? Those then directly control or connect into the control system, and then from there, the user has to adjust the cool intensity or the warm intensity. The problem with this is that when a user walks into this space, they think I want it to be dimmer, or I want it to be brighter, or I want it to be warmer or cooler. They're not thinking, what's the ratio of the cool and warm intensity that I need to adjust by to be able to get the light output and the color temperature I want? And so, interestingly enough, the color mixing has to happen at the user, and for a user that just doesn't compute. They're not used to having to do color mixing to be able to achieve the white light intensity that they desire. So what may happen? Well, first of all, we just want to say that this is not the recommended method. This method only allows for static scenes for both to set the intensities of both the cool and the warm LEDs. You cannot have a manual raise lower or daylight dimming. It's just not possible with this type of technology in the space. And there's no independent control of CCT while maintaining intensity. So if I want to leave the intensity where it is and I want it to be cooler in the room, if source appearance, I can't take a single control and actually adjust that. I still have to adjust both of them. And vice versa, I can't actually control the intensity while maintaining CCT. And it's not supported with the color temperature slider in Quantum 3.3. The second fixture style is known as the intensity and CCT fixture. So this is where within the fixture, there's some sort of color mixing logic. So you can still have the cool LEDs or the warm LEDs, or in fact, actually, you could have kind of a multi-channel where you could have 3 or more as well. So you could have RGB, whatever it is. The part that matters is that the user only has control over intensity and CCT independently. So that way, if they want to dim up or they want to dim down or they want to change the color appearance, they can do so quite easily from independent controls. So the good part about that is that this style of fixture gives you raise lower capability. So you can have raise lower and you can do daylight dimming. That is definitely possible with this style of fixture. Time clock control is very much simplified with this style of fixture. And you can actually adjust them independently. So again, as I said, if you want it to be brighter or dimmer, you walk in the room and you adjust that one control for intensity. If you want it to be warmer or cooler, you adjust the controller for the CCT. And you can actually use the temperature slider in Quantum for 3.3, or in View for Quantum 3.3. So some questions that you want to ask the manufacturer is you want to verify that the fixture is actually a CCT intensity fixture and not a warm cool fixture, because you will likely end up with issues on site if it is a warm cool fixture. So make sure that you ask that question, and then also you might want to ask what kind of protocols that fixture uses, and we'll talk about those in more detail a little later. So I'm going to turn it over to Kendall. He's going to show you a quick demo.
All right, thanks, Craig. So we made a tool to try to help explain what Craig was talking about, the difference between a warm-cool fixture and an intensity CCT fixture. So what I have on the screen now is what the user would see. I have a warm slider and a cool slider. I can adjust the intensity of either of those things. And I have the output of my fixture. So I have my color temperature output and my intensity output. And my objective is I'm trying to set up a scene where the color temperature is 3,500 Kelvin or close to it, and the intensity is 330 lux. So I have no idea what mixture I need for this fixture, so I'm just going to set them both to, somewhere near 50% to start. And I can see right away that my color temperature is way too high, and so is my intensity. So I'm going to start with the color temperature. It's too cool, so I'm going to go to my cool slider and start lowering that down to try to get to 3,500 Kelvin. But as I'm lowering this, you can see that not only is the color temperature changing, but so is the intensity. So I have one input that's causing both of my outputs to change. So now I'm at 3,500 Kelvin, and my intensity is a little bit too bright. So I need to go over here and lower the intensity of the warm slider. So if I lower this down, you can see I start lowering it to 330 lux, but now my color temperature is still not quite 3,500 Kelvin. So you can see how this is a little bit difficult to try to dial in exactly what you want. Now, I've done this a few times, so I happen to know that this is the correct ratio I need. Now, let's say I take that same scenario and I've gotten my sliders to be at 50 and 16, which is what they needed to be to achieve that output. But now I just want to lower the intensity. So I want to keep the color temperature the same, but it's a different scene where I need a lower intensity, 150 lux instead of 330. So I can start by lowering one of these. I know I want to keep my color temperature the same, so let's just say I'm going to lower both warm and cool intensity by 10%. So if I lower my warm intensity by 10%, and then I lower my cool intensity by 10%, now my intensity is a lot closer to my goal of 150, but my color temperature's changed. So even though I lowered them both by the same fixed amount, the ratio between them actually changed, which caused my color temperature to shift. So I really have to try to manipulate both of them at the same time, because each time I move one of them, it's changing the output of the other one. So this can get very complicated, and this is why it's hard to do things like daylighting, like Craig mentioned, because daylighting is exactly what I'm trying to do here. It's just adjusting the intensity, but keeping the color temperature the same. But you have to mix two different inputs in different ratios to do that, and that can be confusing. So I'm going to give up and try a different scenario. So same goal, but now I have an intensity CCT fixture. So my two sliders have changed. I have a CCT slider and an intensity slider. And my output's still going to try to hit the same target. So 3,500 Kelvin and 330 lux. So my original scene one that I created. So I'm just going to throw these up and see where they land. My CCT is a little bit too high, so I'm going to lower that down to 3,500 or close to it. And my intensity is also a little bit too high. Lower that down to 330, and that's it. I'm done. So now let's do the same exercise. Let's say that I need to create another scene at the same color temperature, but lower the intensity. So here, the process is very simple, right? I just go to my intensity input, and I lower this down until I get to 150. Only one output's changing as I move this slider down. And that's why you're able to do things like daylighting very easily with this type of fixture, where you can't really do that with a warm cool fixture. And this demo that I just went through, you can actually access at lutron.com/tunable white demo. So if you wanted to show someone else at your firm, or maybe just go back to it and play around with it yourself, you can access it there.
Thanks, Kendall. So we'll continue talking about the various fixture styles. So when we talk about the warm-cool fixture, again, for all the reasons that we've already talked about, but as well as what Kendall mentioned before, this user experience is limited to scenes. Daylight dimming, because of the fact that you can't actually dim that, similarly, is not practical. And time clock control is just, it's difficult because of all the complexities of trying to determine what those scene values actually are. Just leads to a poor user experience. For intensity and CCT control, this leads to a positive user experience, and you can have independent control of intensity and CCT. So you can see in this particular control, in the lower left corner, you can actually see that there's a raise lower on this one. So you could have that on the color temperature side as well. And maybe actually instead of showing the color temperatures, you would show other things like daylight or warm or whatever resonates with the particular user in the space. That's the kind of language that you may want to have on the keypad. Daylight dimming is possible. If I can have a raise lower, I can have daylight dimming. And time clock control is very much simplified and easy to do with this style of fixture. So let's talk about full spectrum control briefly. Basically, this is something that gives you ultimate flexibility, but can be very complex actually as well. So you can see there around the outside, each of those white dots would be like an RGB yellow in this case, so a red, green, blue, and yellow LED. And then in the very center, you see another dot. That would be probably a phosphor-converted blue LED producing white light somewhere around 3,500 Kelvin. So you could actually produce any color of light within that particular shape. But what makes it very hard is it's very hard to produce a high-quality white light if you, as a user, have to independently control each one of these colored LEDs. So where we see this being used most is usually in architainment type solutions. So this is like exterior facades, or maybe the lobby where they want to touch a color in a hospitality situation. Something like that is usually where we see full spectrum control being used. So in summary, you have warm dimming. That's where you can change the color temperature as you dim, and it replicates the incandescent performance. Tunable white, really what we want to have is independent control over the color temperature and intensity. But let me just say that just because it's tunable white does not mean that you have independent control over color temperature from intensity, again, for the warm-cool versus intensity and CCT fixtures. And then full color tuning, this is where you get the RGB or RGBA or RGBW if you include white. But again, that's usually for the architainment type solutions.
All right, so thanks, Craig. Let's do a quick poll to get us into the next section here. So the poll question is, are you seeing an increase in tunable white specs or demand in your area? So the jobs that you work on, let us know how you think or what the trend looks like. I'll leave that open for a few more seconds. All right, so thank you for answering that. And here are the results. So it looks like the majority are seeing an increase, and then there's still about 20% that aren't seeing any jobs with tunable white in their area. So tunable white is a really big trend in lighting and seems to line up with the survey results we just saw. And if you've been to any industry events recently, it's certainly a hot topic of conversation. So in all of these verticals, office, education, healthcare, hospitality, there are different use cases for this that are really attractive because we have this new knob we can turn on a fixture. So it allows you to do things like have a space that changes how it looks and feels over time. Right, so a hotel lobby, for example, you may want to look very differently in the morning or in the middle of the day than you do later at night, or if there's an event going on at the hotel. It also allows you to do things like tweak how a space looks after everything has been installed. So you may select a particular color temperature for the fixture or have an idea of what you want, But then once the actual materials get installed in the space, you know, the flooring, the walls, the carpet changes color, it can affect how the space looks. So if you have a tunable white fixture, you can adjust it on site while you're there and get it to look exactly how you want it. And then there's a level of flexibility for the end occupants, right? This is another dimension of control you have over the fixture. So in certain applications, it may make sense in a private office or a conference room to give the end occupant the ability to change the color temperature to meet their personal preference. And tunable white's also part of this bigger trend towards what I'll call human-centric buildings. And sometimes I think human-centric is used to mean only tunable white, and you know, we think it really means a little bit more than that. So it's about optimizing the indoor environment for the people in the space, right? So that means their productivity, their well-being, the efficiency of that building. And tunable white's definitely a big component of that, but it's not the only component. So there are other things like being able to see the outdoors and having natural daylight, personal control to adjust how the lighting is in your space. Those are all components of a human-centric building as well. So for tunable white, to implement tunable white in a human-centric building, there are 5 questions that you need to ask on every job. And these questions can help eliminate risk and make sure that the end result is a satisfied client. So first question, what are the control inputs to the fixture? And Craig spent a few minutes going over this, and this is the demo that I gave. Is it a warm-cool fixture, which has limited functionality and can result in a poor user experience, or is it an intensity CCT fixture? And that's really what you want. You want an intensity CCT fixture. It's much more flexible. It's going to end up in a positive user experience, and it'll minimize the risk on the job. So second question, are the control inputs digital? And when I say digital, I mean ecosystem, DALI, or DMX. Those are all digital protocols. The alternative is analog, which is 0 to 10 volt. So why digital? Why should the control inputs be digital? Well, I'll give you a couple examples. With a digital protocol, every fixture gets the same message. If you use 0 to 10, the message changes from fixture to fixture as the analog voltage level drops over the wire run. And this was true today with intensity fixtures, but oftentimes a small difference from fixture to fixture at higher intensity levels wasn't really noticeable. So if you're at 98% intensity on one fixture and 95 on another fixture, you're probably not going to be able to perceive that. But if there's a small difference in color temperature, say one fixture is at 3,500 Kelvin and another one's at 3,600 Kelvin, that difference may be noticeable. And as the size of the room and the length of the wire run gets longer and longer, it can become quite drastic, as shown in this picture, where they have this very neat hallway where one side of it's cool and the other side is very warm, which is probably not the intended design goal for that particular application. Another consideration is the wiring. So there's no change in the wiring with a digital protocol just because you have a tunable white fixture. It's just like a regular intensity fixture. You wire the control wires to it, and everything else is handled digitally in terms of sending information. With an analog 0 to 10 volt fixture, if you add another control to the fixture and you make it a tunable white fixture, you now have to run a separate set of 0 to 10 volt wires to control the color temperature separately from the intensity. And that means you can have 2 sets of 0 to 10 volt wires going to every fixture. And you need to make sure that those don't get mixed up from fixture to fixture. So it's very, very complicated to wire. You're basically quadrupling the number of opportunities that the installer has to make a mistake. And even if they make a mistake, troubleshooting it may be very difficult, right? Because a quick function test of the system, everything may appear to work correctly, but then you find out that when someone is lowering the intensity, you have 2 fixtures that are changing color temperature. So that can be some an odd behavior that you may not notice until later on. The other benefit with digital is it's noise immune. So if you have a 0 to 10 volt run running next to some noisy, phase control wiring in the building, and an elevator turns on or something, you could see your color temperature and even your intensity, for that matter, start to move around a little bit, or temporarily change or shift to a different color temperature because of that interference. With digital protocols, you don't have that same concern. And then the last thing I'll mention is, with digital, you're able to precisely control the color temperature. So in an application where you want to know exactly what the color temperature is in that room, you also need to combine that with shades. So if you combine shades, which allow you to control the biggest source of light and color temperature influence in a lot of spaces, the sun, with digital control, you can really dial in a specific color temperature. And that may be useful in an application like a patient room or something, where you're trying to guarantee a specific color temperature in the space. So digital control options, let's go through those. So a good option is DMX. The downside of DMX is the wiring is a little bit complicated. So it has polarity, which is one thing that needs to be wired correctly. It can be expensive to do emergency lighting. So every building has emergency lighting, and depending on how that's achieved, if you're trying to use the fixtures that have the DMX control in them, it can be a little bit vague. So, for example, the DMX standard doesn't define an emergency scenario. So what happens and what third-party gear you need to bypass that signal can be a little bit difficult to set up. And you always have the potential of compatibility issues. I mean, DMX was intended for theatrical lighting, and if you have different manufacturers making the different components in the system, there's no third-party certification body or anything for DMX. There's a published spec, and manufacturers are responsible to make a product that works to that spec. A better option is DALI. So the DALI protocol has less complicated wiring than DMX. It's 2 wires, so fewer wires, and there's no polarity and no wiring topology limitations. You just land 2 wires on every fixture. However, DALI also doesn't have guaranteed compatibility. You still have the issues that DMX has with the DALI 1 standard, where it's a published standard, but there's no third-party certification process. The DALI 2 standard, which hasn't really taken off domestically, but is just starting to take ground internationally, does have a certification process. However, even the DALI 2 certification process, the new standard explicitly states that they cannot guarantee interoperability, which is unfortunate if you don't find out that the fixtures and the controls don't work together until you get on site. The other downside or drawback of the DALI protocol is it's limited to 90-second fades, which might not be an issue, but in a tunable white application, you're likely going to have a sequence of operations that requires a long fade. And if you're limited to 90 seconds, that can be somewhat constraining when you're trying to create a sequence of operations. And then the best option here is ecosystem. So because we make both the control and the component in the fixture with partners like Luminetics, who have embedded ecosystem control into their modules, we can guarantee the compatibility and performance. So those are a huge benefit, right? All right, if I use the ecosystem in the fixtures and the controls, I know it's going to work on site. I know I'm going to get the performance I need. And the other benefit of ecosystem over DALI is it supports long fades. So you can do up to 2-hour fades, and you can stack multiple 2-hour fades back to back to do a really long change over the course of the day, which is very common sequence of operations for tunable white spaces. And then to summarize the 0 to 10 volt, this is the analog option. You can see there are many wires going to the fixture, typically 4 wires to each fixture. I mentioned the voltage drop issue. This can be confusing to wire. And then the other drawback is there's actually multiple 0 to 10 volt standards that conflict with each other. So one of them, defines where the source of power should be. The other one defines a different source of power. It's probably not clear from looking at cut sheets which one you're dealing with. So it's not the best option for tunable white. So a third question that you want to ask is, what are the max and min CCTs for all of the fixtures that you're using? So if you have a fixture that has a minimum CCT of 2400 and then another one that has a minimum CCT of 3000, you're not going to be able to achieve 2700 throughout the space uniformly because one of those fixtures doesn't have the same range. And there's quite a bit of inconsistency out there. If you look at an offering of tunable white fixtures, even within the same manufacturer, you'll see that there are different starting ranges. So they might have some that go from 2,000 to 5,000, others that go from 2,500 to 6,000. There's quite a big range out there. And again, if you have two fixtures with different ranges on the same analog loop, so let's say you wire 0 to 10 volt to two fixtures and they have a different CCT range, then even if they're getting the same signal, they're getting 5 volts on the 0 to 10 line, they're going to be in the middle of each of their respective ranges, which will be different values if they have different ranges. So the fourth question we want to ask is the fixture a two-color white or a multicolor LED fixture? And the reason why this is important to ask is if you're using a two-color tunable white fixture, it's not going to follow the black body curve. You're going to have a warm strip that in this example is around 2300 Kelvin and a cool strip around 6000 Kelvin, and it's going to move linearly on the chromaticity diagram between those 2 points, which means it won't follow the black body curve. Now, if you have a multicolor LED fixture, so it has more than 2 light sources in it. So in this example, you could have a third light source that was somewhere in the green area of the chromaticity diagram in order to stay on the black body curve. So now as you're moving from the minimum CCT to the maximum CCT, you can follow that curve. But if you mix these two fixtures in the space, even if they have the same CCT range, which they both do in this example, right? Their starting and ending dots are in the same spot. In the middle of the range, they won't match because one of them will be on the black body curve and one of them will not be. So you'll have this mismatch in the middle of the range. They will look different in the space. And then the fifth question that you need to ask is, what is the sequence of operations going to be? Because this can be really important when you're trying to match the control system and the fixtures. So you're likely going to have to meet code, right? So you'll have daylighting and occupancy. Is there going to be a time clock control? How long are the fades? And does your choice of fixture and the protocol in that fixture support that fade? What are the manual overrides? What are the manual overrides effects? How long do they last? Where's the color temperature actually going to be measured in the space? So if you're defining it, is it measured at the fixture or is it measured somewhere in the space? We would recommend measuring it at the fixture and defining it there because everything in the space is going to affect that measurement. And are the shades controlled? If you're trying to maintain a precise CCT and you're not blocking out the daylight, then you don't really have control over the color temperature if there's any daylight in the room. So I want to do a quick poll, and then Craig's going to go through an example of a patient room sequence of operations and some of the considerations. So this poll is, what space types are you seeing tunable white in? And you can answer more than one. So if you're seeing it in multiple space types here, feel free to check them all off. All right, getting some good responses here. And a lot of this lines up with what we've seen so far as well, is that it's used in a variety of space types. And it kind of depends on the job, but really all of these space types have different applications, and the solution that you want in one might be different from, the solution in a private office is probably different than a hospitality public area. So, all right, Craig, if you could go through an example.
Yeah, so just going to talk through a patient room, sequence of operations that you might want to think about. And again, the whole reason why you would do something like this is really to improve the experience for the user, right? So when we talk about the right environment, we really care about what the user is going to experience, and we think it through each of the different outcomes, how they interact with the system and what their needs are. So the first thing is if you just think about some automation that could happen behind or in the background. So the gray bar that's going to show up may be the intensity, and the orange bar would actually be the color temperature, and this may be what you decide to have happen throughout the day, right? So as an example of what you could do, it increases intensity in CCT in the morning, it kind of levels out mid-morning, comes back down in the afternoon, and then kind of stays steady until later in the day when the CCT drops again. So, this simple time clock functionality, you can actually start to think about, how do I want my system to act in the background, so that way the user in the space doesn't necessarily have to think about the color. So here's an example of a patient room, right? Pretty typical. You walk in the space and there's, the entry or the staff area right there. The next area is the lights that are for the patient. And so maybe there's a keypad on the wall, or maybe there's a pillow speaker there for them to be able to control their lights as well. The last area would be where the family is, so they control their two down lights. And then there's a restroom, right, for them to be able to turn on the lights in that area, so there's a down light and a linear as well. So there's a linear above the patient bed, there's a linear in the bathroom, and then the rest are down lights that you see there. So it seems very simple, right? We define the sequence of operations as, here's what the keypads do. The keypads go to full on, high, medium, low, and off. But there's a lot more to it than that to be able to get this right. Some questions that you might want to ask are, how long does that override actually last? How quickly do the lights return to the automation that we described previously? And should the lights automatically turn off ever? Or should the lights automatically turn on? Or how long does a patient in bed, or sorry, how does the patient in bed shut off all the lights? So traditionally, people have thought about design as, well, if I have a switch there, I'm controlling the lights above the patient area. But now with digital systems and the ability to have one keypad actually control all zones of lighting in the room, maybe the off button for the patient should actually be able to turn off all lights. So if I'm a patient in bed and I'd like to rest, but the nurse left the room and left the staff area on, now I either have to get out of bed or I have to call for the nurse to be able to turn the lights off. Maybe it's appropriate to have the off button actually turn off all lights in the space. So there's some additional functionality if we start thinking about the user and how they would likely operate the room to be able to improve that user experience. So, and again, we talk about this as far as how does this all interact. So you see the gray bar that actually covers, or the gray area that covers there. Maybe the lights don't actually automatically turn on for the user until a certain time of day. So maybe in the morning, if they turn on their lights, they automatically go into this whole automatic sequence in the background. But if they don't, maybe around 10 o'clock in the morning, the lights are just automatically going to come on to their level they're intended to be at if they haven't been on yet. But in the middle of the afternoon, you see there, maybe around 1:30, the patient wants to dim the lights to be able to relax. So they hit the medium button, and you can see there that we know the lights are going to go down to, in this instance, it would be about 15-foot candles. But what happens after that? How long does that green bar extend to the right? So is it an hour and a half? Is it 2 hours? Is it 1 hour? What is that override duration? And the next question is, like, how long should it take to actually come back to automation? We showed that, or talked about it, but now you can see it really matters whether or not I'm going to take an hour to come back, I'm going to take 2 hours to come back to automation, or maybe instantaneously I come back to the automation. All these things are questions that you need to ask about the particular user of the space. And maybe certain users are more tolerant of changes than others. And so, thinking about that duration actually really does matter.
All right, so now let's talk about the different phases of the job and how Lutron can help. So in the early phases, schematic design, design development, we have what we call system sales engineers. So they're experts, technical experts out in the field. They can help review your sequence of operations, and as Craig was just mentioning, sort of point out any open questions like, how long does the override last, for example? Do we have the right protocol to support this fade rate that you want? All of those things we can help verify as early on as possible. We can also work with OEMs to get the right controls in the fixtures you want. So if there's a particular type of fixture and we identify that early on, we can work with the OEM to try to get an ecosystem solution into that fixture. And we can also help match sort of the controls and the fixture types and the protocol types across the whole job. So we may need different solutions in different spaces, but we can work with you to make sure that we're going to have something that can really achieve the sequence of ops and also meet the needs of the client that you're working for. In the later phases of the job, when we get to construction documentation and construction administration, the same things are true. We can still review the sequence of operations. If there's been any changes, we can look at it, or as we further define things, get feedback from the end user. Whatever it is, changes to that sequence of operation have a big impact potentially on what control gear you need. So we can help go through those again. And we can also build a submittal and review the lighting package to make sure that any intensity CCT fixtures that you spec'd weren't subbed out for warm and cool fixtures. So that's really one of the most important things, and that's why we started with that one first, is making sure that you have the right fixture type, because you don't want to have to change fixtures on site, right? Very expensive, very inconvenient. So making sure you have an intensity and CCT fixture is very, very important to minimize the risk. So where can you go for some information here? We've been throwing a lot of information at you. We have a website, lutron.com/tunablewhite, that links to all of these resources that I'm going to mention here. We have in-person demos that we could do. If you want to demo a tunable white fixture or you want to see a demo of the Luminetics performance, we can do that in person. We also have a tunable white CEU that we can give for AIA credit. So if you don't know who your local Lutron SSE is, talk to your Lutron rep. They can arrange a CEU presentation. We can have the SSE come in, and that'd be a good way to meet that person and build that relationship. And you get AIA credit. We also have an application note on our website. That's on the Tunable White website up at the top of this slide. And we have that online demo available that I showed earlier, which anyone can access. So that's publicly available. You can show it to other people in your firm. And this webinar. So this webinar will be made available to all the attendees, and we'll send the link out after that gets published. So you can also share this with anyone else. If you had a couple people at your firm that you thought might be interested in this because of some jobs they're working on, feel free to share that as well. So let's dig into the actual solutions we have a little bit. I mentioned Luminetics in a previous slide. So Luminetics has a really high quality light source. They actually have 5 different sources in their actual light engine, which allows them to have a really high quality light and follow the black body curve. It comes in different form factors. They have solutions for downlights and troffers, and their module actually has ecosystem embedded into it. So you don't need a separate driver or anything. You just land 2 ecosystem wires onto a fixture with Luminetics into it, and that's it. So it's a really nice solution. It's a really high performance solution that allows you to achieve really, really great light in a space. And even if you don't see a Luminetics option on fixtures that you want to use, that doesn't mean that we can't get them in there. So both the Lutron and Luminetics OEM sales teams are ready to work with you and the OEM that you want to work with to have them offer a Luminetics solution. So if you're working on a job and you say, yeah, this sounds great, but I don't see this option on the cut sheet and I want to use this fixture, pull our OEM sales team in, talk to your Lutron rep, We're offering this solution with a lot of the big fixture manufacturers, but we're certainly willing and able to go and get it into as many fixtures as possible. We also have this tool that we call the Lutron High Performance Fixture List. You can access that tool at lutron.com/HPFL. And we recently updated this tool. So in the left-hand side, there's a search filter, sort of like when you're doing a search on Amazon.com or something. One of the filters now is you can check off tunable white. So if all you want to see is show me what's available for tunable white fixtures, you can check that box. And I think there's several hundred fixtures on there, and we're always adding more to that list. I also want to show you Quantum 3.3, which is the current early adopter version of Quantum. So this is available now. And what we've done is we added a color temperature slider to the lighting tile in Quantum View. If you haven't seen Quantum View, you can also get a demo of that. And that would be another great opportunity to have the Lutron rep or the local SSE come in, do a tunable white CEU, and get AIA credit, and then give you a demo in person of both tunable white and Quantum 3.3. The key to this, like most of what we've talked about today, is the fixture needs to be intensity CCT. If it's a warm-cool fixture, you don't have this level of flexibility to adjust intensity and color independently. And this slider in the Quantum GUI will support all load types. So ecosystem, DMX, Dolly, even 0 to 10 volt, as long as it's an intensity CCT fixture, you can use this interface to control it from Quantum View. And the other way that you can control things in Quantum View is directly on the floor plan. So for the facility team, sometimes it makes more sense for them to just go to sort of a graphical floor plan of their space, especially if there's lots of zones, there's a very large space. Now, if you go to a graphical floor plan and you click on a fixture icon, and that fixture is tunable white fixture, you'll see the ability to change not just the brightness, but the color temperature right on the floor plan. Also want to point out a job that we did very recently. The American Society of Interior Designers had a big renovation on their headquarters. That was the first space in the world to earn both the LEED and WELL Platinum certifications with the latest versions of those standards. So you may have seen some articles written about this. I think there was an article in Architectural Lighting and LDNA. They're using tunable white fixtures, and our Quantum system is controlling both the lights and the shades on that job. So to summarize what we've gone over here, 5 questions that you ask on every job. Those are key points. If you know the answers to all these 5 questions and you're able to justify why they should be intensity CCT fixtures, a digital protocol, common max and min ranges, and define the sequence of operations, you're going to be successful on a job. And our call to action for you is to use intensity CCT fixtures, use the resources that we've talked about, involve Lutron as early as possible in the job so we can help at all stages of the job. We can get a Luminetics module or an ecosystem solution for the fixtures that you want to use. We can give presentations to end clients to explain the differences and the drawbacks between different fixture types. Our goal is to help minimize your risk, help you satisfy your client. So if you have any questions, feel free to type that in to the question field in the GoToWebinar, and we will send out answers to any questions. I'm going to do one last poll, and that will conclude our presentation. And again, you'll get a brief survey, a couple of questions right before you leave. If you can answer that, we would definitely appreciate it. So the last poll question is just about how often tunable white gets VE'd out of a job, which is one thing we've heard, and we expect that the trend is that it's starting to actually be implemented on more and more jobs, but we'll see what the polls say. All right, we got a majority who have voted, so let's share the results here. Yeah, so this is in line with what we've seen for most jobs. It gets VE'd out, but it's definitely growing overall. So we're seeing more and more jobs that are implementing tunable white. And actually, so what's surprising is there's a significant percentage that say it's rarely VE'd out of a job. So in certain regions, it may be more popular than others. So appreciate your attendance and your time. We will send out a follow-up to all of the registrants later on with a link to the recorded version, so you can access this or share it with other people at your firm. Appreciate your time. Thanks for joining the webinar. Hey everyone, if you're still here, we were just letting some questions roll in. We're going to close the webinar now, and we will follow up with email to anyone who has submitted a question. Thanks again for your attendance.